Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to this SecurityBoulevard.com program, brought to you by Techstrong and Scycode. My name is Cody J. Brown. I'm the host of Techstrong Learning, and we have an exciting presentation ahead. First, I do need to cover just a couple of housekeeping notes. First, today's session is being recorded, so if you miss any of our discussion, or maybe you'd like to rewatch or share with a friend, the on-demand recording will be made available shortly after we conclude our live session today. If you have any questions, and we really hope you do, we want you to send those in to us using the Q&A tab, which can be found on the right side of your screen. Over on the right side of the screen, you'll also see a chat tab, and we'd like you to reserve that for more general comments. Let us know your thoughts throughout today's program, maybe where you're tuning in or what role you play in your organization. And of course, before we close out, we are giving away 4 $25 Amazon gift cards. So be sure to stick around for the duration of today's topic. So today we'll be discussing Understanding SBOMs, a practical guide to implementing NIST and CISA's software bill of materials requirements. Today I am joined by Julie Peterson, Senior Product Manager at Scycode. Julie, it's wonderful as always to see you again. Thank you so much for joining me. I'm going to let you take it from here.
Great. Yeah, thank you everyone for joining us. It's a kind of rainy, gray day where I am, so I hope the rest of you have better weather. I am a Senior Product Marketing Manager at Scycode, and I have worked in tech my entire career, and the last few years have been in the security space. Past employers for me include Mend, which is formerly White Source Software, IBM, and IDC. And I'm going to be your tour guide today. So our session agenda is we're going to start with talking about software supply chain security challenges. We're going to dive into what is an SBOM anyway. And then once we kind of lay out the minimum requirements of an SBOM, I'm going to talk about some of the limitations and gaps that we see, and including how you can bridge some of those gaps. And then finally, we'll end it with a Q&A. So feel free to add your questions in at any time. So we're going to begin with software supply chain security challenges. And, we've all seen the headlines. It's not a surprise. Everyone knows about SolarWinds. These attacks are growing not only in frequency, but also in intensity. And it's at the point where Gartner is saying that nearly half of us will have experienced some sort of software supply chain attack by 2025. And that is a threefold increase from just last year. So it's a significant and growing problem. Why is it such a problem? Well, we're seeing that attackers are shifting their priorities. We've done a pretty decent job of locking down our applications in production, but one of the things that has been an oversight for many organizations until quite recently has been the software supply chain itself. Now, you're all here because you're concerned about software supply chain security, so this isn't a big surprise, but all of our the tools that make up your software supply chain are tightly interconnected. And so if you're able to infiltrate one of them, you can move laterally throughout the system. We're finding that these kind of attackers are staying in systems for longer undetected and doing a lot more damage. And then also, instead of attacking just one organization, an attacker can then spread their attack downstream to customers, and often those downstream customers are really the primary target. So again, we're seeing that attackers are going after what's relatively easy compared with production applications, and that is why we have such a rise in software supply chain attacks. So before I go too much further, I want to just define what I see as a software supply chain. And I figured the easiest way to do that was to correlate it to something that we're all pretty familiar with, which is a traditional supply chain. So in this case, it's a car. We'll say it's a Ford F-150. And, Ford has a number of components that they manufacture in-house. So think like your engine, your drivetrain. But there's also a number of components that they outsource from third parties. So it might be a brake pad, it might be an infotainment system, or a windscreen. Then in a traditional manufacturing line, there's your infrastructure, your manufacturing line, and then you have the workers who are putting everything together. And when you think about the software supply chain, it maps pretty nicely to a traditional supply chain in that you have your custom code that is designed and built in-house. You have dependencies that you pull in. So think of open source dependencies or other third-party components that you don't necessarily have control over and you don't necessarily have full visibility into, but you use in your product nonetheless. And then you have your DevOps tools and infrastructure that build your software. And finally, the developers and even the DevOps people who are putting everything together. And so today we're talking about SBOMs, and SBOMs are basically an inventory of all of these third-party components. The idea is to gain more transparency into the things that you don't create or control on your own. So the interesting thing about modern application development is that the vast majority of our code bases are made up of application code dependencies like open source components and third-party components. And the problem is that your downstream customers don't often know what is in your software. So maybe they trust your development practices and they know that your proprietary code has been developed and tested in a secure way, but they might not know what those third-party open source dependencies are made up of. And so again, they need transparency into this to make a full assessment of their risk when using your software. So again, a number of high-profile attacks, specifically SolarWinds, prompted the US federal government to release an executive order, and this was May of last year. The executive order on improving the nation's cybersecurity basically identified cybersecurity as a top national security issue and economic issue. And the federal government decided or wrote this executive order identifying that in order to be successful in stopping these types of attacks, that there needed to be a partnership between the public and the private sector, that the public sector couldn't solve this issue on its own. And the overarching theme of this executive order was to increase transparency. And transparency is a big word that you'll hear a lot about today. And one of the ways that the federal government decided was a good way to increase transparency was by requiring a software bill of materials for each product that they purchase, right? So they want to prevent against that SolarWinds type of attack that they were the victim of. And so the software bill of materials is now a requirement for doing business with the federal government. Now, what we see when the federal government makes a edict like this saying that you need to provide a software bill of materials is we see that this slowly becomes the adopted standard in the industry. And why is that? Well, if you're selling to the federal government, you need to create a software bill of materials. If you are selling to a company that sells to the federal government, you need to create a software bill of materials. If you're selling to a company that's selling to a company that sells to the federal government, and so on and so forth. So that's how it kind of becomes the de facto standard. So we're really seeing an increase in sort of the activity and buzz around SBOMs. And so to that effect, the federal government has set out some guidelines, and we're going to be talking about those today. But I'm going to first start with just a basic definition of what is a software bill of materials. At a very high level, it is a formal record that details all of the components in your software, all of the things that go into building your software, as well as the supply chain relationships between those different components. I like to think of SBOMs as a list of ingredients for your software. So here we have some delightful lemon ginger scones, and those lemon ginger scones come with an ingredient list. So if you have any dietary restrictions, you can scan that ingredient list and really fully understand what is in those delightful and delicious lemon ginger scones. So SBOMs enumerate all of the components, third-party open source, that are in your product, and it's useful for a number of different users. So developers or manufacturers can use an SBOM to ensure that all of their components are up to date, right? Are they pulling the most recent version of the library? Or if there's a new zero-day exploit announced, they can then quickly respond to any of these vulnerabilities. Buyers can use an SBOM to evaluate their risk of using your product. So they might be using it for license information or vulnerability analysis. But again, it gives them transparency into what you're providing for them. And then the downstream users can quickly and easily determine whether they're at risk if, say, a new vulnerability is discovered. One of the things that's really important to always remember about SBOMs is that they need to be, by definition, machine readable. And we'll talk a little bit more about automation in just a bit. But following on my lemon ginger scone here, and it being a list of ingredients, if you look at it, the list of ingredients contains atomic parts, so things like flour, sugar, baking soda that are just their basic piece that can't be broken down into anything smaller. And it also has compound parts, something like crystallized ginger or lemon drops, which gives the scones all their taste, are made up of other things. So if you're looking at an SBOM, in the middle, here you are, your King Arthur Baking Company. And if you're in the Northeast, you're probably familiar with their flour and their baking supplies, but they're putting together this great scone. And so they identify all of the parts and compound parts in their scones. Now they want to sell their scones, and so they are have an arrangement with an operator. In this case, it's a grocery store. Groceries are us. And the grocery store sells to their downstream consumers. Now, the grocery store wants to make sure that they are giving full transparency to their downstream consumers on exactly what is in these scones that they're selling. And so the supply chain relationship looks something like this, where you have all of your parts feeding in. You have the person who is assembling it, and then the operator can give this ingredient list, this SBOM, to the downstream consumers. Now, where you have parts and compound parts, it's not really fully transparent. You might have an issue where one of the downstream consumers has a severe food allergy. And so the operator wants to make sure that they're completely transparent, because they don't want, frankly, one of their customers to go into anaphylaxis and potentially die. They don't want to kill off their clientele. So they want to be as transparent as possible. And so therefore, it's really important when you're creating an SBOM to identify what are all of the parts in those compound parts. And so if you look, the crystallized ginger is ginger and cane sugar. And the lemon drops, oh gosh, by the way, have a bunch of things that go into it, including milk. And your customer down here has a really severe milk allergy. So by giving this full detailed level of transparency, they can understand that they can't eat these scones because it might kill them, right? Because it does contain milk. And so if you think of this as, your parts, your compound parts, like your open source libraries, and giving full visibility in, so that both your operator can understand whether it's safe and secure to use, and your downstream customers has that information. You can think of an SBOM as like a list of ingredients for your software. Now, the NTIA, in conjunction with NIST and CISA, has put out a report entitled The Minimum Elements for a Software Bill of Materials. And it says it right there in the title. These are just the minimum elements. So it's the baseline starting point of where you should be. And the NTIA, which is under the Department of Commerce, says that you should have three main buckets of information that make up your SBOM. The first one is data fields, so the actual data about the components that are in there. You need to have automation support, so the SBOM needs to be generated automatically and in a machine readable format. And then you need to have certain practices and processes around how your SBOM is created and distributed to your customer. So we're going to dive into each one of these a little bit more deeply. So the first thing is data fields. So your SBOM has to contain information about each component, and that should be tracked and maintained and always up to date. Your data has to be in a consistent and uniform structure, and this is a little bit of a paradox because it also needs to be flexible. So consistent, uniform, and flexible don't necessarily always go together, but the truth of the matter is that this is a immature technology, and so the flexibility is required as it matures. Now, what are these data fields specifically? So the first thing you need is a supplier name. And if you can see here, this image is actually the header of an SBOM for the King Arthur Baking Lemon Ginger Scones. And it has a supplier name. So if you're looking at an open source, it might be something like Apache, and the component name might be Spark or a specific library. The version of the component would be 2.2.2. And then you might have other unique identifiers, like say a database lookup or something that is unique to finding information about a specific component. Then an SBOM also identifies the dependency relationship. So is this a primary dependency? Is it a transitive dependency? Then you need an author of the SBOM data, and the SALSA framework from the OpenSSF basically says that they believe that this should be a build service, so it should be automatically generated at build time. And then finally, you need a timestamp so that you can correlate an SBOM with a specific version of your software. Now, if we look, this is actually one of the components. This is sugar, and it is identified as a first level component. We have the supplier, it's from Domino, and then we have the relationship here specified. So it's lemon ginger scones contains this particular sugar. There's no licensing or copyright information in it, but this is just an example of what an SBOM might look like. And I want to also just point out that this is an SPDX format SBOM, and we will be talking very shortly about several others. So in terms of automation, the SBOMs need to be automatically generated. It's just not a process with the number of components and the complexity of them to do this manually. And so the automation of it is really important. In addition, you need to be able to scale across organizational boundaries. So you need to be able to get information potentially from various tools or repositories to build the data that is in your SBOM. And so you need automation to basically get access to these different components to build your SBOM data. Now, machine readable is really important because it's not just about generating data, but it's about what you do with this data. And so there are 3 recognized outputs for SBOMs. They are SPDX, or Software Package Data Exchange, Cyclone DX, and software identification tags. Now, each of these have a slightly different flavor and a slightly different use. I think probably SPDX might be the more popular, but there really is not one dominant format yet. So SPDX is a format put out by the Linux Foundation, and they have really focused on sort of structuring the data in a way that's easily repeatable. This is the only standard that is ISO certified. So if that is a concern for you, this is the standard that you'll be following. Cyclone DX is a framework that is put out by OWASP. And so therefore it's no surprise that security and data integrity is built in a key component for Cyclone DX. And it is considered sort of a lightweight bill of materials first format. And so it's popular for that reason. The SWID tags are primarily used for licensing concerns. So if you're somebody who's concerned about licensing, this might be a format that you're using. So those are the key outputs for an SBOM. So the next and third bucket that the NTIA has defined is that you need to have practices and processes around how your SBOMs are created and distributed. Now, the interesting thing is that they actually haven't set firm guidelines on it, but they're just telling you that you need to define internally within your own organization what your practice is and how what your processes are around these. So the first one is frequency. How often is your SBOM updated? Now, ideally you want it updated with every build. With SaaS suppliers, if you're updating multiple times a day, that can be, quite a technical debt to carry. But again, that's something that you need to decide internally, is how often you are updating your SBOMs. Depth, again, is also really important. It sounds like a no-brainer that you should be including all primary and transitive dependencies, right? So you want to include everything. The issue here is that when you include transitive dependencies, it can be quite complex, and it sort of brings up another problem to solve. And so if you look at this image here, this is actually a dependency tree for the NPM project. And if you look at it, and actually this is really only the center of the dependency tree, I couldn't zoom out far enough and still actually have NPM readable, but it shows all the dependency relationships of NPM pulling in other projects and other libraries. And so as you can see, SBOMs can be really, really complex when you start pulling in all of these other transitive dependencies. Really important, but a complex problem. The next thing that the federal government would like you to consider when you're creating an SBOM is identifying what you don't know. So your known unknowns. There are going to be situations, and think of dealing with like a legacy application where you might not necessarily have the source files. And so you might not have a full picture of what all of the dependencies and the relationships are for that particular application. So in this case, you need to identify what you don't know. You need to identify whether your information is either incomplete or just simply unknown. And that is, again, gives transparency to your consumers so that they can make an accurate assessment of the risk that they're willing to take on given what you know and what you don't know. The next sort of practice and process that the NTIA is asking you to determine is how you are going to distribute and deliver your SBOM. So there needs to be some way that you are advertising its existence, whether it's in a release note or another vehicle, or a well-known place that your users know to go for. And then also the timely delivery is extremely important. If you have an SBOM that comes out 3 months after, it's going to be out of date and irrelevant. So again, being able to deliver something timely is really important, and you need to define a practice around this. Access control. So you might not want to publicly publish your SBOM. You might only want to limit it to certain people within the organizations that you're selling it to. So this is something that you need to decide, and then you need to decide where this is outlined, where this who has access is actually spelled out. And that might be in your licensing agreement. It might be determined in contract negotiations. But the point is that you need to identify who has access and where it is specified. And then finally, the last thing that the federal government would like you to do is to have a process in place to accommodate any mistakes. Again, this is an immature technology. Trying to manage supply chain data is still something that everybody's trying to figure out. It's an evolving process. It is inevitable that despite best faith efforts, that mistakes will happen. And so you need a vehicle in place to correct those mistakes and notify people that there is a mistake in your SBOM data. So again, these are the baseline criteria as set out by the federal government. And I think if you look at it, you'll probably guess that there's a few things that are missing, right? Again, this is the minimal requirements as specified in the report. So in the next section, I want to go over what I think are some of the limitations and gaps, including some ways that you can bridge these gaps to create a better SBOM and to really lock down your software supply chain and make it the most secure it can be. So the federal government is pretty transparent in their admission that there is still room for better visibility to secure your supply chain. And they have acknowledged that with the gaps that currently exist, things like the SolarWinds attack would have still happened, right? Because a lot of times the attacks are on the tools and systems themselves that are used in building your software and not necessarily on the code. And so SBOMs, as they're defined right now, only look at the application code, and so might not catch everything they need to. So that brings me to my sort of first limitation, is that SBOMs in their current configuration only identify application code dependencies. And so what I mean by that is any dependency that's pulled into your application code itself. So think all of your open source libraries and all of your third-party components. Now, those are really important, and certainly you need to have visibility into each and every one of those dependencies. However, if you look at your entire SDLC, there's a whole host of other dependencies that you're just not looking at when you're building your SBOM. And those include things like the dev tools themselves, right? So dev tools are pieces of software that interact with your software to build and deploy. And we see attacks like this happen in the wild all the time. Just over the summer, GitLab announced that they had a patch for a critical vulnerability that allowed for remote code execution. If you look back to SolarWinds was attacked via its JetBrains TeamCity server. And so again, these tools need to be considered, and you need to capture sort of version control of these tools in your SBOM so that if there is a vulnerability, you can determine whether you are affected by that. Now, build tools also have plugins, and think of plugins or something along the lines of like Circle CI orbs or Jenkins plugins, which you would buy in a marketplace, and they are used to expand the functionality of a particular tool. And they themselves are made of pieces of code that have their own dependencies and might have their own vulnerabilities. So the point here is it's a dependency that you haven't created and that you don't maintain and you don't have control over, but yet you're using to build your software. So you really need to understand how that could potentially impact it. And point in case, Jenkins announced in early July this year that they found 29 different plugins that had a total of 34 security vulnerabilities in it that put your application at risk. So an SBOM should capture the data of what kind of plugins you're using so that, again, it can find information later on should a 0-day be announced. As you move further down your pipeline, you can look at build modules, things like GitHub Actions or GitLab Runners, which again are created and maintained by third-party people that you don't necessarily have control over it, and should therefore be disclosed to the people who are consuming your software. So in this case, we have the Try and Web IDE, right? That's a build module created by Red Hat, and it's going to impact your software. It could be a backdoor in at some point if there is a vulnerability associated with this. Build modules as well pull in their own dependencies. And just like any other software, they have open source libraries, and those libraries can include their own vulnerabilities. And therefore, this is something that you need to be able to disclose to your downstream consumers for full transparency. And then finally, IAC can introduce its own dependencies. So IAC, infrastructure as code, uses software to provision cloud infrastructures in a repeatable fashion. These templates can run scripts or pull in packages, and those packages might have their own vulnerabilities. So again, you need to identify the IAC templates that you're using to create a full transparency. By expanding the definition of what we consider a dependency from just your application code to encompass your entire SDLC, you're better aligned with what is really happening in supply chain attacks today. So by identifying not only dependencies in code, but dependencies in your pipeline, you can really help lock down your SDLC. And by including all of this extra dependency information, you can also identify at what phase of a life cycle this dependency comes into play and could potentially impact your application. The second challenge that we see today with SBOMs is that they currently just contain a list, an inventory of the components. They don't actually contain any vulnerability information. And so an ideal SBOM is something that would contain both vulnerability information as well as prioritization data. So vulnerability information could be something like the CVE itself. For prioritization, it could be a CVSS score. A lot of solutions out there have this idea of reachability where they can look at various libraries and look at what functions are being called in production to determine whether a vulnerability is reachable or not. So in this top level, there is a direct call to a vulnerable function, but in these next two levels, there isn't. And so you can effectively deprioritize these vulnerabilities. Well, wouldn't it be great if you actually have that information in your SBOM itself? So you can say, hey, look, here's the dependency relationships. Yes, there might be a known vulnerability, but it is not executed at runtime. It's something that you can effectively deprioritize and still be assured that you have a secure solution. The third challenge with SBOMs right now is that really it's just a file that's not necessarily secure. And that in itself can be problematic. What's to say that an attacker couldn't come in and actually tamper with some of the data? So the third capability in an ideal SBOM is that the integrity and authenticity of the SBOM itself is verified, that it has not been tampered with, and that it actually does match the data in your application itself. And then, ideally, each SBOM is signed using public cryptography standards so that users can determine whether the signature is legitimate and that the data that they're getting is actually what should be there. And then, they can use the SBOM to compare against what they're actually receiving and make sure that they match. So again, a really important capability is making sure that you're able to verify the integrity and authenticity of your SBOM. The fourth challenge, and this again goes back to that supply chain piece that we're trying to solve, is that SBOMs aren't able to understand your pipeline configurations or security postures. So SBOMs right now are just focused on your application code. They haven't expanded their reach into what your pipeline is made up of. And so if you look at most development shops out there, you have multiple teams, and often those teams are using different tools. Say you've standardized all of your teams on one set of tooling, then you have an M&A, they could bring in their own tooling. And sure, eventually you'll get them ported over to your standardized set of tools, but that can take months, 6 months, a year easily to do that. So what you end up with is you end up with a really complex pipeline that is using a lot of different tools, and they are usually implemented by developers to make sure that they're optimized for speed of development. They're not generally optimized for security. And so SBOMs just don't even look at these, and so they can't tell you whether your pipeline is secure. And if you think this doesn't happen, the state of New York actually had an incident where they had a server exposed to the internet, and it had the default password, so it wasn't, deployed in a secure manner. And you could just go in, anybody could go in and sign themselves up for an account and give themselves admin permissions, and then basically do whatever they wanted through the whole state of New York. Now, here's the thing. If you're not able to understand your pipeline configuration, you don't need a vulnerability to get in. You just need to know what the default password is. And this happens a lot of times. So it would be great if you had an SBOM that could actually identify, again, all the tools that are in use and look at the security controls and policies that are in place and making sure that best practices are being followed. Things like implementing least privilege and branch protection rules, authentication settings like multi-factor authentication, right? So wouldn't it be great if your SBOM could say, hey, look, your application was built using a secure pipeline. Because again, you don't need a vulnerability if you have a misconfiguration. It's a much easier way to get in, and it happens all the time. And then the fifth and final challenge that I'm going to talk about today is that SBOMs are currently static, right? They're a snapshot in time. And while it's absolutely great to have this transparency with the speed of deployment these days, they are, almost immediately out of date. And so in our Super SBOM, we have the capability to dynamically generate it basically on demand. So it's done automatically, dynamically, so that your SBOM is always reflecting what is in your application, right? So it's giving you your direct transit dependencies, your pipeline tools and configurations, all your vulnerability data. And then, hey, guess what? Because it's dynamic, it can expand into and identify what your cloud-based or third-party application stack looks like, because it's always on and running. So again, that would be an ideal way to generate an SBOM. So essentially, what we have today is some minimum requirements that are making steps forward, but we definitely need a more complete approach to move software supply chain security forward. And the best way to do that is to adopt tooling that can look at your entire SDLC holistically and that can understand how the events are happening, not just in your application code itself, but all the way through your pipeline, and can make sense of everything as it goes together. So when you're looking for an SBOM solution, look for these enhanced capabilities. Look for something that gives you visibility deeply into your entire SDLC and your software pipelines. Look for a solution that can identify all your dependencies, not just the open source libraries in your application code. Yes, those are important, but it's not everything, and it's not even where a lot of the attacks are happening these days. Look for an SBOM that can handle vulnerability and remediation advice that can give it to you right in the document itself. And then finally, you want to make sure that you can have an SBOM where the data integrity is constantly verified and can look at all of your tooling. So just to recap our session today, we all know that software supply chain attacks are a large and growing problem. And as I think you can see from the minimum requirements that we've outlined, security is an evolving process. It's not a final goal, right? So we're always kind of evolving. SBOMs are a great first step and should have data fields, machine readable, and processes in place regarding distribution and consumption there so that you're more transparent for your customers, but also recognize that these aren't perfect. And in an ideal world, we believe that your SBOMs should identify all of the dependencies that impact an application and could provide an attack vector for a malicious actor, that they contain vulnerability and remediation data, that they're securely generated and distributed, and that they're able to understand security tooling as well as dependencies. And then finally, that they're always updated and accurate. So before we get to the Q&A, I just want to talk a little bit about who Scycode is. We are a complete software supply chain security solution, and we offer two different buckets of tools. We have scanners that look for vulnerabilities. That includes SAST, next generation software composition analysis, or what we call pipeline composition analysis, container scanning and IAC scanning. And then we have a whole set of tools that help you hard your pipeline. So pipeline security and governance, code tampering, hard-coded secrets, and code leakage. Now, all of these tools sit on top of our graph database, which we call our knowledge graph. And what that does is it connects and correlates all the data from our scanners and our configuration tools, and basically gives you a complete picture of how events relate to each other so that you can get a really full picture of your security profile and risk. And with that, I thank you for attending today, and I would love it if you have any questions to put them in the chat right now. And thanks very much.
Awesome. Great, great, Julie. So let me see if I can kind of paraphrase some of the questions that are coming in. Well, here's one that's probably, at least I don't have to do a lot of reading. The first question is, what tools are out there that can create these SBOMs, right? I mean, and just to elaborate a little bit on that, you've touched on a couple of different capabilities and kind of what's defined in terms of what the government's asking for, and some empty areas that.
Yeah. So yes, that's great. So there's a lot of software composition analysis solutions or SCA vendors out there that can generate an SBOM, and I think what we find is that most of them are really focusing on that application code piece. And I don't want to downplay that. That's, it's really important to understand open source is such a big part of the way we develop. But there are all these other dependencies, and you hear all the time about all these other attacks that are coming in through the tools themselves. And so you need a software composition analysis tool, or what we're calling a pipeline composition analysis tool that gives you visibility into the whole pipeline. So it looks at all of these, dev tools and plugins and can identify them. And so, we here at Scycode have something that we're calling pipeline composition analysis, because it's like a superset of software composition analysis, and that can generate some of these more advanced, pipeline. It gives you visibility and transparency into the pipeline. So I think look for tools like that aren't just looking at application code, but are expanding their reach to look at many other, dependencies that are out there, right? Think of it, a dependency is anything that you don't create, you don't own, and you might not have visibility into. And so that's what you need to tell your customers about. And there's so many of those out there, dev tools, plugins, build modules, and things like that. So that's, I think, what you should look for in a tool.
Yeah, great. And that actually reminds me. I mean, I really like your food analogy around kind of allergens that might be present in the food, and thinking about when you're talking about getting visibility into the pipelines. I just keep thinking about all those little notices. If you've ever read the nutrition labels, at least in the U.S., they say things like, this product was processed in a facility that processes tree nuts, or milk and yeast, or whatever other types of things are there. Those are the types of things that an SCA style SBOM is not going to include, because it's not included in the application. It's something that's part of the environment within which the product was created.
Yeah.
Awesome.
Yeah, definitely.
Okay. The next question: are there best practices, around how SBOMs are created, and what we do with them?
Yeah. So I think, there aren't hard and fast. I think, I went over some of them, like in terms of advertising, or like, let's say sharing SBOM data. You need a way to advertise it, and especially as it's this emerging technology, you need to let your consumers know that it exists. And so maybe that is by, I don't know, a URL that has product information in it. Maybe it's in your release notes, or maybe it's always in the same well-known location that your customers know to go through. And then in terms of like access to it, maybe it's always in a repository. Maybe it's not the most secure way, but maybe it's always emailed to your consumers. So I think there's still developing best practices on how to share it. In terms of how to generate one, I think we outlined some of them today. It has to be automated. It has to be with each release, ideally. It has to include as much data as possible. Again, I think as much data as possible is still under negotiation, but those are some of the best practices that we have now. Again, it's a very fluid environment that we're still working on defining. And there will be a lot of changes over the next, in the very short term, I believe.
Yeah, it makes sense. I mean, there's just so much that we're learning as we go through this process and hear from the various stakeholders. Like as software developers, we kind of know what we're creating, but maybe we haven't heard a lot of input from some of the the users of our users who may have other requirements that we need to filter into this at some point.
Right.
Well, I guess that kind of begs the question, and this is actually another question that I see here. What do you do with the data from all of these SBOMs? I mean, if you have an SBOM for every component going into this thing, whether it's your application or the tools that are used to build the application, what do you do with all of those different SBOMs?
Yeah.
How do you make sense of it, right?
Right. Yeah. I mean, that's a great question. We've been so focused on generating them, right? Like solving that first problem, that what do you actually do, right? Generating an SBOM, generating this list does not make you more secure. You actually have to do something with that information. And I would say probably hiring a summer intern to read through it is not the best solution. So yeah, what do you do with all this data? Well, I think you need a solution that can ingest all of the data and correlate the information. So we're going to be inundated with dependency data, and so you need a way that a solution that can ingest all of it and analyze it and find trends and patterns, and then really give you a full picture of what really is a risk. Maybe it's something that can identify where a vulnerability is in code and whether it's been tracked through to your production environment. So again, I think, that is an ever evolving thing, but definitely you need a solution that can break down the silos that are so inherent in security right now, to kind of look at the big picture of your development environment and then make assumptions and analyze it to actually prioritize and present your data, so that you can have actionable insights, right? It's all about consuming this vast amount of data in a way that is actually useful for you. I don't know if you have anything to add, John.
Yeah, no, and it's interesting, right? I mean, you have all of that information, and something that is a risk to somebody, it may not be a risk to others, right? Because you mentioned earlier kind of that reachability concept of if there is a vulnerability, or in the case of an SBOM, maybe it's an unknown that's documented in the SBOM, right? If your application or the way that you're using this dependency doesn't ever touch that piece of it, then you don't care about it. But if the way you use it does touch into one of those unknown areas, then that's something that you may want to explore a little bit deeper and be a little more proactive in terms of finding out whether you really do have a risk there or not, even if it's not completely documented in the SBOM.
Right. And, and again, it is giving this information so that consumers can make informed decisions, right? So maybe a consumer might have very different standards if they're looking at something that touches their PII or financial data versus something that maybe is just like an internal productivity tool. So again, there is no one size fits all, but definitely there needs to be a way to make sense of all the data.
Yeah, great. Okay, yeah, one more. So the things, I'm just trying to process it here before I say it so it doesn't come out not making any sense. So the things you described sound good, but how do you fit these practices into today's current standards or development processes, given that some of the capabilities that are required of SBOMs seem pretty limited, or at least limited in scope?
Yeah. Wow, that's a great question. Well, so I think I want to just go back to most of the information that I presented here were the minimum requirements. And again, it's that baseline. NTIA, NIST, CISA, they understand that this is always evolving, it's growing, it's maturing. And again, flexibility was in there. So Yes, I don't think you need to feel limited by the data structure that's there now. I think that there is this understanding that as we get greater visibility into more parts of the application process, that we're going to have to expand and enhance the data that we're offering. So again, I think don't be constrained by what's current. It's going to be changing, and if you need to change it, then again, change it. So it's still very fluid. It's still open for growth, and I think there's a lot of opportunities out there.
Okay.
Is that it for today?
Well, I actually see one more question over
Okay.
in the chat panel, asking how. Well, I think they just want to understand a little bit more about specifically what Scycode has to offer with respect to the 5 challenges of SBOMs.
Yeah, well, so one of the great things is that Scycode is able to, so because we connect with all of the different tools that make up your pipeline, and we scan for a whole host of security issues, and it all sits on top of this graph database that can identify relationships and really make sense of what a risk is. It's able, our solution is able to break down the silos that you often find in security. And so again, instead of looking at just one piece of the puzzle, we can actually look at the whole thing and make connections to help you. So I think that's one of the things that we do. Anything else you want to add to that, John? I mean, but just like really taking that step back and being able to give a full picture instead of like putting a microscope on just one piece. And we do both, right? So we're putting a microscope on one piece, but we're also saying, how does that relate to these other pieces? And where is the threat really, really a huge issue versus something that's not reachable?
Yeah, true. And I mean, it's probably another area that we're looking at is, in addition to what you get out of the SBOMs, if you're using some sort of an SCA tool that can generate an SBOM and tell you which packages you're using in your application, for example, the knowledge graph also has all that visibility into the development process and the development environment. And what happens over time as the application is built and deployed and operating out in runtime. All of that visibility can also be factored in to the SBOM, which I think is really powerful. It gives you that visibility into which build tools you're using and the modules of those build tools and the dependencies of those modules, right? As you were explaining all of the different types of dependencies, that's something that the knowledge graph really provides that that can be really hard to get otherwise.
Yep, definitely. 100% agree.
Well, there was one more question about whether the slides will be shared. I believe
the recording is shared, and maybe it's a great time to bring Cody back in, and he can give us the final winners of the gift cards and talk about sharing of the recording.
Perfect.
Yep, absolutely. Thank you, Julie, and John. Thank you for sorry. Thank you, John, for handling the Q&A for me as well. I really appreciate your help there. So as far as the slides, we don't have a copy of them available on our hand. We would need to have Julie send that to us after the fact, and we'll make it available on the on-demand. Or we can also have those emailed to you in a follow-up email as well. All right, so on to those 4 winners that Julie mentioned. This is for 4 $25 Amazon gift cards. Our winners are Gilbert B., Catherine H., Lynn R., and Nicholas P. So to our 4 winners, congratulations. Keep an eye on your inbox to claim that gift card, but if you don't happen to see that email, please do check your spam folder. I'd like to thank Scycode for sponsoring today's program, and to everyone who joined us today, thank you for spending the last hour with us. We really value your time, and we also value your feedback. So as soon as we close out, a survey will pop up on your screen. We'd really appreciate you filling that out for us tell us what we can do better going forward, or tell us what you liked about today's program. But regardless, we do hope to see everyone at an upcoming Techstrong Learning program and hope that everyone has a great rest of your day. Julie, John, thank you both so much for joining us.
Thank you.
Thanks, everyone.